Hi guys, we're going to cover sections B and C of chapter 7 today. Follow along, okay? So there's different types of chemical reactions that we're going to talk about, and you can kind of see what's happening with the different elements with the reactants and the products in this diagram. The first one is a synthesis reaction, and that's when you take two separate reactants and combine them into a more complex product, okay? Decomposition is the opposite of that. And so you start with a complex compound and then as a reactant, and then you break them apart. You actually split them. Digestion is a form of decomposition because it's breaking the molecules apart, the compounds apart to use as nutrients, okay? Then we get two different types of replacement reactions. One is just called a replacement reaction. And it's when one element trades places. Okay, so you can kind of see, that the B and the C traded spots here. Okay, but then you can get a double replacement, and so it's a double swap. Okay, instead of AB, you have AC. Instead of CD, you have DB. Okay, and so they two different elements traded spots. And then not indicated in this diagram here is another type of reaction. It's just a combustion reaction. That's anytime something burns, okay? So when a fuel is reacting with oxygen, that's combustion, right? There's another kind of reaction, kind of a general reaction known as a redox reaction. And that involves this process known as oxidation and this process known as reduction, okay? Oxidation is when an element, mostly metals, frequently metals, reacts with oxygen, okay? When that happens, that metal or that element loses electrons, okay? When that reaction happens, this is known as an oxide. So that's the compound that's formed by that oxidation. But because of the conservation of mass, we know that those electrons can't be lost, all right? They have to be absorbed by something else, okay? So the reduction portion of this reaction is when those lost electrons are taken up just by another element in that reaction. You can't have oxidation without reduction, and so frequently these reactions are referred to as redox reactions because the reduction and the oxidation are both occurring, okay? Energy does different things in reactions. Let me move my camera down a little. There we go. We had talked about this in a previous lecture, the fact that energy is either absorbed or released in all of our chemical reactions. But that brings us to some new vocab, okay? Exothermic reactions, so that would be this guy over here. Exothermic reactions release energy, and it's frequently released as heat, okay? Combustion is an example of that. And so once that reaction takes place, you can actually feel the heat. Endothermic reactions absorb energy, and so they tend to feel cooler. That would be that ice pack that we talked about, okay? We also deal with this thing known as activation energy, and that's just the energy required for a reaction to start. Some reactions don't happen automatically, okay? I've lit a match before in class. I can hold the match and it's not going to light. The friction that I add to it gives it that activation energy for that reaction to occur. Again, that law of conservation of energy has to come into play. No energy is created or destroyed in these reactions. It's just changed into a different form, okay? And frequently that's heat. Boy, that was easy. That was breeze past compared to the last lecture, right? That's all I got.